So guys, just a quick look at the question there for 2010, higher level developments. Okay, so I want to start this up high up on the sheet. You'll see why afterwards. I want to keep this elevation up high in the sheet. So I'm going to start it off there with, it's a radius 48 circle. Because I want to space down afterwards for the development. Now if you're working on A3 sheets like I am here, you're going to want to start this up high. Okay, now the step down 21. And this just slopes out at 60 degrees. And there's our elevation completed. So the next thing we want to do here is our end view. So it's vertical up the left side. Just bring across these heights. So just leave a small gap between them. It doesn't really matter how much. So it's vertical up the left. And it sticks out 24 here. And 260-degree slopes. Nice question, because there wasn't that many measurements involved in setting it up. So there. Okay, so here is section A and here's that surface B. Now, the question asked there, so to draw the elevation, draw the end view, then draw a plan. So I'm going to just set up my 45-degree line here to project. So again, not a lot of lines involved in this. As I said, a nice question because it does test the understanding. So I'm going to bring over my distances here. So just project them down. So here is the back. And on the ground, which I'm going to draw first, it comes out to here on the ground. Okay, and then it slopes back into here. So this is just joining the dots, or joining the slopes here, join the dots. So that's the flat surfaces there. I guess that's B. Now all that remains is to be done here now is the curve. Now I do know that one point in the curve is here. So I'll just zoom out there a bit. So what I've done here is my front view, my top view. I've done the flat surfaces, but I don't have the curve done, and the curve sticks out. So what I'm going to do here now, just work through it nice and slow, is I'm going to just divide up that curve into 6 equal parts. Now it doesn't have to be equal parts, but I just will, because we're going to use that later for the development then. So break that up into 6 equal parts. It's like the times on the clock: 5 past, 10 past, quarter past, and then quarter to 10 to 5 to. So I'm going to just number these. 1, 2, 3, 4 is the highest. 5, 6, 7. I'm going to bring these across, so that would be 4. This would be 3 and 5. This would be 2 and 6. And that there would be 1 and 7. So there are all the points on my curve as this, the roof of the stadium comes out. So I'm going to project these down and over. So I've already got 4, which is here. So I'll do 3 and 5 next. Bring them down from the elevation. Bring them down from the end view and across. So that's 3 and 5. Then I'll do the same with 2 and 6. So bring them down, across, and down from the elevation. So there's 2. And 6. So I'll just draw this curve. So there's our curve drawn there, and finally there's just underneath line here, that solid surface running along here. I'll fill that in. Hidden detail there as you're looking down from above. So that there's the curved roof of our stadium. So the question said draw a plan, which is done. Draw the development of the curved surface A. Now, I am going to draw the development of the curved surface A next, but I'm going to draw, just project it down below here. I'll just zoom back another bit there now so that you can see what I'm doing. So I'm projecting it down from here. Now, if that was a full semicircular stadium roof with no curve chopped out of it, I would be just taking this distance here, which is 1/6, because there's 6 of them in this curve. So I'm just taking this and I'm going to start. And now that I'm finished my projecting, I'm going to just start here and I'm going to just draw it on top of. Now I'm marking these in a bit heavy so that you can see what I'm doing. Okay, I wouldn't really do it quite as heavy if we weren't recording it. So if I'm starting off here with this one, so I'm going to say that that's 1, 2, 3, 4, 5, 6, and 7. So if this was a full semicircular roof, it would be just a rectangle like this. Okay, but it's not because of this curvy slope cut out of it. So I'm going to just draw light lines up from all of these, and I'm going to project down here in a second where each of these gets cut. Okay, so 1 and 7 come out this far, so I can just mark 1 and 7 are cut there. So again, you'll forgive me, I'm putting these rather big dots on this now, but there's 1 and 7. Next I'm projecting down 2 and 6. So I'll just dot them. Then 3 and 5 are cut here. And finally 4 is the one that comes out the most on top there. That's not cut at all. So I'm just drawing this curve here now. So again there, just get a feel for where that curve is going. And I'll just heavy in the outsides of this now. So that there is the development of our curved roof. So that's the development of A here. So the other thing we wanted was the development of B. Now there's several ways you could have done this, but I'm going to maybe look at 1 or 2 ways that this could have been done. So my surface B here, so this is it over here. So I might just color it in to help people to see it. So this is surface B. In plane, but that's a sloping inclined surface. It's inclined up here at an angle of 60 degrees. So I'll just heavy in the edge view of it here. So hopefully this will help people to see it. So there's a few different ways that I could have got the true shape of this, but for me the easiest one would be to just stand that up straight by rotating it vertically here. So if I rotated that up until it's vertical, I'll just put it in here now in green. So instead of sloping in, I'm after standing that up vertical. And now I can bring the height of this across. And if B is over here, now the top of it now is going to move up that little bit higher up to here. So I'll just draw it in with a pencil. So that moves up straight to there. And back down to here. And I'll just color in the true shape there now, so you can see it's after getting a bit taller. Okay, now that's one fast way of getting it. Now, another way I could have got this if I wanted is, I know there if I measure this on the ground, okay, so on the ground that there is, I'm getting that that's 37 millimeters. So I could just transfer that distance out here and measure 37 millimeters. So that's the base. And I'll just project that up there, and we know that this distance here, if I measure that there, that's 25. So when it's standing up straight, it's 25 high. So I'm just going to measure 25 high. Okay, so that's my height. And the top of it then I can also get from here, because that's horizontal here. This is a true measurement. That's 25 as well in this direction. And that there is the true shape. I'll just put TS for true shape on that. And I'll colour it in as well. Like that is another way, because there's lots of different ways of getting the true shape. One will do. And like I could have also just rotated this down onto the ground to the horizontal plane and brought that down and knocked B down onto the ground here in plane. That's another way of getting it. So so yeah, that is that. That's 2010.